پروفسور گودا که در خدمتشون خواهیم بود به عنوان سخنران کلیدی دوم هم یکی از عزیزانی هستند که در این رشته شهرت جهانی دارن و ایشون هم دکترای مهندسی عمران و سواحلشون رو از دانشگاه توکیو 1976 اخذ کردن و در این ارتباط هم در سطح دنیا صاحب نظر هستند. مدت‌های مدیدی استاد دانشگاه ملی توکیو بودند. از ایشون دعوت به عمل میاد برای سخنرانی کلیدیشون که در ارتباط با بحث برنامه‌ریزی برای حفاظت از سواحل در برابر افزایش سطح طرز آب دریا هستش در خدمت شما باشیم. با یه تشویق
Your Excellency, ladies and gentlemen, this is my honor and my great pleasure to be invited to deliver a keynote speech. And as you may remember, this is my second opportunity to come to Iran and attend ICOPMAS. And I found, compared to the 4 years ago, ICOPMAS has been expanded greatly. What I remember 4 years ago, the conference was held in one session only. Now this time you have 3 sessions and also workshop. And I really congratulate the progress of your port and coastal maritime technology here. Thank you very much. And today's my presentation is coastal protection planning against sea level rise. I am not specialist on these problems, but I found the theme of the conference is the effect of climate changes, and I try to review available literature and try to present to you as much as simple. And okay, so my content is past and future sea level rise, adaptation coastal against sea level rise. These 2 topics are all coming from this IPCC report 2007. So if you want to have more detailed information, please search this website and from where you can download full report. Then I introduce adaptation plan against the sea level rise at several countries. Then I don't know if you have any specific coastal protection plan, but I just try to give you my personal advice how to make Iranian coastal protection if it is necessary. Then damaged coastal protection measures. This is from again IPCC. Then as I'd like to talk about something about countermeasures against beach erosion. Okay. Now, when we look back at our history, then sea level rise was not uniform, constant. And back to the 125,000 years ago, sea level was up plus 4 to 6 meters higher than us, according to some scientists. Then as the Stone Age came, sea level dropped very deeply, and around, say, 20,000 years ago, it came to around minus 120 meters. Then it gradually rise up with average speed of 1 meter per century. And but in Japan, it becomes stabilized in the past several thousand years. But in Japan, we have experience of the 3 meter high level about 4 to 5,000 years ago. It's we call it Jomon transgression. And just before Professor Dean discussed more detailed analysis of the sea level rise, this is the what IPCC people collected various data and made some synthesis. And IPCC is essentially is a compilation of various available data. So IPCC itself doesn't make any analysis. So, and for the before this 19th century, the sea level was almost no change. But in 20th century, there was as Professor Dean said, 0.17 meters per year rise. Then in recent is the IPCC report said there was a increase, sea level has increased. And for the coming 1 century, there are variety of prediction. Like it depends on how the world manage to the economic growth and the scenario. So there are many scenarios. Scenario A1B is the world economy continue to grow with the present level, but the B1 is all country cooperate to reduce the CO2 emissions. And this shows the contribution of thermal expansion to the global sea level rise. And the sea level rise is come from various sources, mostly thermal expansion. That means as the global warming, surface of seawater, maybe 200 meters deep, is getting warm, so expand, so that. But there are many other factors, and depending on this is the worst scenario, which is going to be used by the Dutch people. But dynamic change of ice sheets, melting ice sheet and flowing out from Greenland, Western Antarctica are not included in this production, because at the time of 2007, their mechanism was not clear, so that there's, because of uncertainty, the IPCC did not consider this one. But there is some warning. Ice sheet melting may be quite dangerous. And for the Dutch people, they made a coastal protection plan back to the 2006. At that time, they made this, but they revised the Delta Commission report 2008 now. This has a 0.65 to the 1.2 meters by 2100. And by 2200, they make a preparation of much higher sea level rise. These are not scientific prediction, but this is a baseline from which the Dutch people prepare the adaptation plan. And the coastal system to cope with system, that storms, waves, sea level rise is increase of external dispersants, and there is a natural subsystem, coastal system will respond to that. Then selected example in the plan adaptation, and IPPC has many chapters concerning, depending on the sector. If we look at the infrastructure or settlement sectors, adaptation strategy is the relocations or construct seawalls and storm surge barriers, then dune reinforcement and such. And to make full use of it, there must be good standard regulations and land use policy and the preparation of good building code itself. And the such planned coastal adaptation practice has evolved from the 1990, 1997, 2001. So, sorry. Yes. So it became more detailed. It's okay. Yeah. So, I think this ICOPAS secretary will have a copy of this slide, so that you can ask the secretariat to get copies later and have a more detailed study. Now, so against the sea level rise, several countries are preparing adaptation strategy. The Netherlands is the national planning is made Delta Committee for the period of the 2100, 2200. But the city of Rotterdam has its own plan by the year 2025. Then in the UK, the Thames estuary plan is going on. In Japan, we are making various studies, but we have not materialized any specific plan yet. Then, for example, in the case of Delta plan, as you know, Dutch coast, as the 6% of the hinterland is below the sea level. So the coastal protection is a vital policy of the Dutch people. And now they are taking the plausible upper limit at the worst scenario, so that to make a safe preparation, so that, as I said, it's a 0.65 to 1.3 meter by 2100. And they're proposing raise the safety level in all dike areas by a factor of 10, and they are also considering the flood discharge will increase. And the Dutch government is continuing beach nourishment with a huge annual cost of 1.0 to 1.5 billion euros. They plan to continue it. Then this Delta Commission report says that it is necessary to enactment of Delta Act with creation of Delta Fund, so that their funding will be permanent. Now, for the Thames estuary, this is to develop flood management plan for the London and Thames estuary area. They say flood management, but it means actually means protection against storm surge. And they make a three-stage planning: the first 25 years, the middle 35 years, then the last 30 years. So flood protection level is going to be raised by 0.4 meter at the present level by 2040 and such. Then the initial first 25 years, they are going to maintain and improve existing flood defense system with the 1.4 billion pounds. Then the middle 35 years, they going to renew and replace the Thames tidal defenses, which include the very, very famous Thames barriers with this amount. And the quite interesting or important thing that they are going to review and update their plan every 10 years with the flood risk monitoring, so that they are going to make a long-term operations. Now, in case of Japan, first of all, I'd like to tell you that the characteristic of Japanese coast. The total length coastline is about 34,000 kilometers. And these coastlines are divided under 4 jurisdictions: port area, fishery port area, agricultural reclamation area, and general coastal areas. So these 4 divisions are administered by 4 government bureaus of 2 ministries. So this is a small problem for administrative point of view, because they try to communicate and sometimes succeed, sometimes they don't get agreement, so that at the junction between the 2 zones, there may be some difference in the construction of sea defense work. But anyway, among this total length, 9,400 kilometers coastline has been provided with protective facilities such as dikes, seawalls, and others. And those facilities are listed in the government catalogs. And we have enacted sea coast law in 1965 after we have suffered from severe storm surge disasters in 1940s and 1950s. This has been revised recent, 10 years ago. And the major coastal risks in Japan are storm surges, high waves, beach erosion, earthquakes, tsunamis, subsidence by groundwater pumping. I think in your country, the subsidence near caused by groundwater pumping may not be severe, but I'm not quite sure. But if it exists, the groundwater pumping near the coastline must be strictly monitored and regulated. And the current annual budget for coastal protection is about $1 billion US dollars. So it's not so large compared to the Dutch people. Now, currently, 4 ministry bureaus are preparing adaptation policies. And the Japan Society of Civil Engineers has a coastal engineering committee. This committee is making a study of effects of climate change on the shore protection adaptation strategy. Another committee is asset management of coastal protection facility for the, from viewpoint, life cycle cost. And of course, any area which is a danger of, near danger of damage is make a site-specific review of existing shore protection facility and the design works. Now, so as I said, I don't know about your countries or what is your policy of coastal protection, but if we are going to prepare or revise it, this is my personal advice. First, enactment of coastal protection law. Then prepare the good national design standard guideline for coastal protection. Then designation of coastal districts and sectors, each province. I don't know, it's a providence, department, or prefecture, but anyway. Then formulation of GIS assisted coastal information system, and identified hot spots or most dangerous spots, and prepare the hazard maps, which includes the plan for people, the safety, something. Then prepare adaptation measures, and of course you have many experts in academicians, consultant people, and your government should mobilize all the people to make a good national plan. Now, for example, as a coastal protection, as an example, Japanese Sea Coast Law has in Chapter 1 general that define terms and designate coastal protection zone. Then Chapter 2 discuss administration coastal protection zones, and principally, coastal protection is responsibility of prefecture governors. But central government also support facility construction. And to do the good administration, technical standards must be established. Then expenditure concerning coastal protection zone is based on the sharing principle, partially bared by central government, partially bared the prefecture government and municipality as well. Then, and such and such. Now, as for the prevention national design standard, there are various guidelines or manuals available. Of course, you know that. Then, first of all, ISO standard 21650. This is action from waves and currents on coastal structure, which was issued by 3 years ago. Oh, I'm sorry. Yes. This ISO standards does exercise regulatory power if any country prepare a national code because of the World Training Organizations. Then Coastal Engineering Manual by U.S. Army Corps of Engineers has a very large quantity information with some 2,700 pages. But then Japan has 2 manuals, or 2. One is design manual of coastal facility, prepared by the Japan Society of Civil Engineers, which was prepared in support of Sea Coast Law in Japan. And this has been translated in English. And also, Japanese Port and Harbor Authority has been having a port and technical standard and for the port and harbor facilities. And the 2007 edition has been translated English And it's also voluminous, nearly 1,000 pages. And you can refer to the rock manual by the UK, Dutch, and France devised theaters. And there are many technical information on coastal work. Although it says rock, the use of rock in hydraulic engineering, but they make a nice review of the waves, currents, and beach erosion problem, and many things. So this is good to refer to. Then what I say, the coastal district sector is that this is the first step in coastal protection planning. The Iranian coastline is to be divided into a number of coastal districts according to the jurisdictional divisions. Then each coastal division is further divided into a number of coastal sectors by considering coastal sediment cell. I mean, in that cell, the sediment movement is self-sufficient and independent of the next cell. Then gather community information in each sector, how many people are living there, and what are the property of that. Then survey the post and the present state of beach morphology, and then make a catalog coastal facility. Then for the GIS-assisted coastal information system, the objective is to develop and strengthen the marine and coastal information in a systematic manner. By using the GIS, we can put various information in a very organized manner. Main component information are topography maps, bathymetric charts, area photographs, satellite images. Now we can look at Google Earth. It's a very nice means. The oceanography information, tides and waves, coastal geology information, and records of coastal disasters in past. And not only current maps, but try to collect all the maps, charts, other information in the past. And I noticed that now you are developing wave maps in the Persian Gulf, Oman Sea. But there are a number of the wave forecasting data bank available at the meteorological institute, such as ECMWF. So preparation of the plan for the selected coastal sector, that is the first identification hotspots most vulnerable to coastal damage. Then classify what is the danger, what is the damage. Either inundation, sea level rise, or storm surge by strengthened or cyclones, or urban flooding, beach erosions. Then prepare the hazard maps and estimate the possible damage. And after that, you may make a design coastal protection facility and cost estimate. Then you will negotiate for the project financing for relevant authorities. Now, for the, this is, I didn't put here, but this is taken from IPCC report. So depending on the damage, like a small island inundation, in this case, only way to relocate people. And then the storm surge, dike seawalls, tide barrier, like Thames barriers, the storm surge shelter, which is recommended, like Bangladesh, where that's the construction of any facilities difficult, so that to provide shelter, there's a high ground building, so that people can take refuge there. Urban flooding and beach erosions and tsunamis. And as for the distance of the beach shoreline retreat by sea level rise, you can use Perbrun's model. And the important thing is the estimation depth closure, which is some special terminology in sediment problem. So please forgive me to give more explanations this time. Then first, the beach erosions occurs by various causes. There are natural process, anthropological influence. Natural process, the subside underground by tectonic movement with earthquake. When earthquake, big earthquake occur, then some areas subside. Then the sea level rise. But the most common causes erosive action of waves and currents. And anthropogenic influence decreases sediment supply from rivers by dam construction and such things. Then if you build a breakwaters jetty along the sandy beach, that will obstruct alongshore sediment transport. It will cause the severe erosion. Best example is the port of Colombo, Colombo, Madras. Now it's called Chennai. It started construction in late 1880s and built breakwaters. Then now, from south side of the breakwaters, shoreline advanced very 5 meters per year, something like that. And then also, if you provide coastal protection works someplace, then it may reduce the erosion sediment supply to the next coast. And if people pumping out groundwater too much, then the ground subside. And this is happening now. Shanghai in China, and it used to occur in Tokyo, Osaka in Japan also in the 1940s, 1950s. Now, beach erosion, source of beach sand. Where does beach sand come from? One is the remain of continental shelf sand emerged through Holocene translations. And then sediment discharge to river. This is most important. So that if you reduce the sediment discharge, there immediately occur beach erosion. Then the collapse of cliffs, then the littoral transport adjacent beaches, and biological production. Bivalve shells, coral sand, they do produce, depending on the location, that they do provide a good amount of sand. So this, it's called coral sand. Now, if any place in your country has a beach erosion problem, the first step is the field study. Identification of causes of beach erosion at site, and evolution, how the shoreline changed in the past. The second step is the strategy of countermeasures. You have a beach morphology model, but it must be validated with the past record. Most of the morphological model is a numerical model, has quite a number of empirical coefficients. Those coefficients must be compared with the past record. So if you don't have any past record of shoreline change, it's a problem, and your prediction may not be so reliable, and such and such. So concluding remarks, the sea level rise is a slow but confirmed process. We have to face sea level rise and prepare for its consequences. So adaptation plan should be revised every 10 years. So continue monitoring sea level rise, local sea level rise, and tides and waves, etc. And establish an institution organization responsible for the adaptation plan, specific coastal sectors. I think I see that them here. You have the organization that may be a good candidate. And the protection facility, if you're going to build dikes, seawalls, they need to be heightened and reinforced as design water level and wave heights are raised in some futures. And and there must be enough room for future improvement. I think this concludes my presentation. My talk is very broad and not specific, but to try to convey what parameters or what phases you have to consider to prepare the adaptation plan. And thank you for your attention.